Hey, welcome to this lesson on falling objects. Our student objectives in this lesson are to apply what we know about vertical motion to falling objects. The essential question, what is special about falling objects and how we can model it using vertical motion. Below you'll see the Common Core standards. So I put up in the top right corner the vertical motion equation. And we're going to do a real life example of a falling object. So say an acorn falls from a tree branch that is 32 feet in the air. We'll get a little creative here. Say I got a tree and it is 32 feet up in the air. So I got this, here's my ground. Alright, we'll call this the ground. This is 0 feet. And say there's a little acorn right there. And this is at 32 feet. That's going to drop straight down to the ground. And that's our scenario. Draw my acorn a little better. It's 32 feet in the air. How long will it take until it hits the ground? Well, that's a great question. Let's start with this vertical motion formula. So we're looking for a height of 0 feet, right? So if I want to know when it hits the ground, that means h is eventually going to be 0. So I want to know what is t when h is 0. So I'm going to substitute 0 in for h. I'm going to leave negative 16 t squared. I'm not going to do anything with t because that's what we're looking for. Okay, plus my initial velocity, again, is 0. The acorn's not moving until it starts to fall, until it releases from that tree branch. So 0 for velocity times t plus my starting height, which is 32 feet. Okay, so anything times 0 is 0, so that middle term is going to be 0. So I have 0 equals negative 16 t squared plus 32. Now let's solve for t. So I subtract from 32, negative 32, negative 16 t squared. If I divide negative 16 on both sides, I'm going to get 2 equals t squared. So if I take the square root, I will get t equals plus or minus square root of 2. Now I have positive square root of 2 and negative square root of 2. Which one am I going to use? Well, having a negative time doesn't make much sense. So we can say it's not negative square root of 2. It's not that. We'll only keep the positive version. Right, so it would take about square root of 2 seconds to fall to the ground. And we'll finish up with one more problem. Another real world example. I'll get my pen out and draw this for you. Daredevil is driving a car straight off a cliff. So if I got this, and then I got some rocky cliff here. Let's see, Daredevil's driving his car. Let's make it a pickup truck because they're easier for me to draw. So he's taking his pickup truck and he's going off the cliff. He's going to go straight off. Now, he's not just going straight down. There is some, velocity going that way. But for calculating how his vertical velocity or his vertical distance that he travels, that's not going to affect it. So we're only going to look, like I said, we're only going to look here at his vertical velocity, his vertical distance traveled, his vertical motion. That's all we're looking at. Okay? And it is not affected by how far to the right he's going to go. Alright, so the Daredevil is driving straight off the cliff, and the cliff is 1,300 655 feet above the ground. Again, we're going to say this is the ground, and the ground is 0 feet. Okay? How long does it take to dare, into a river, not just the ground. So we'll draw some water there for you. We'll even make his car, let's make his car green. Race car green. Alright. Alright, so when he first comes off the cliff, yes, he is moving to the right, like I said, but is he moving up and down at all? And the answer to that is no. So he's going to be falling down. He's not moving, right before he leaves the cliff, he's not moving up and he's not moving down. So he has no vertical velocity. So let's solve this out algebraically. So we want to find when the car is going to hit the water. So the water's at 0 feet here. So that means I'm going to put a 0 in for h. And then I'm going to be solving for t. Whenever you see how long, it should tell you, ding, 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 I'm solving for t. Because t is in seconds. So negative 16 t squared. That middle term, again, is not going to be there. So I'm going to go right to my starting height, which is 1355. Sorry, I'm going to add 16 t squared to both sides and get positive 16 t squared equals 1355. I'm going to divide each side by 16. When I do that, 1355 divided by 16, that's going to give me, 1355 divided by 16. It's going to give me 84 and 6800ths. So t squared equals 84.68. And if I take the square root of both of those, I'm going to get t equals plus or minus the square root. And it's okay if you use a calculator here. If you want to reduce the fractions, that's fine too. So the square root of that answer is 9.2. So, plus minus 9.2. So remember, we don't want the negative part, we only want the positive part. So it will take about 9.2 seconds to fall. So that means he has 9.2 seconds to get out of that car before it hits the water. I would even tell him to jump out way before then, because you don't want to jump out of the car right before it hits the water. You want to give some time to get away from the car. That's all I have for you today. I hope you enjoyed the lesson. Hope you learned a lot. Make sure you go back through, make sure you really understand everything, and then go ahead and give your homework assignment a try. If you have any questions, make sure you go back to your notes. If you need my help at all, feel free to contact me anyway, whatever is easier for you. And I'll be sure to come to live class and we can go over some more examples.